A gravity survey involves the precise measurement of the gravitational pull, G, at close stations along the track using a very sensitive instrument called the gravimeter. Positive deviations from the regional average indicate heavier rocks, whereas negative anomalies imply a relatively lighter rock. A grid of such survey line allows us to map the anomalies across the area. The analysis of these anomaly maps give us an indication of the underlying rock types and structures. Magnetic surveys are primarily carried out to calculate the depth of sediments in a sedimentary basin and to locate major structural features within it. The principle used in magnetic surveys is based on the fact that different rocks have different magnetic properties. Those that have relatively higher magnetism cause very small effects in intensity and direction of magnetic fields. These effects are measured and mapped in a magnetic survey. Since most of the magnetic materials are contained in igneous or metamorphic rocks, the relative strength and sharpness of magnetic anomalies is controlled by the depth of occurrence of these rocks. Since these rocks usually constitute basement, the depth below the surface can be interpreted as the depth of the sediments in the basin. The two most commonly used seismic techniques are the reflection and refraction surveys. Both of these techniques use the principle of travel time of sound waves through a formation. In reflection surveys, a small charge is exploded in a shallow well called the shot hole. Receivers, or geophones as they are known, are placed in a straight line on either side of the shot hole. Energy from the blast spreads in different directions, and a part of it travels down through the subsurface. Wherever it encounters a change in density of rock, it gets reflected upward and gets recorded on the geophones. This process is repeated across a series of stations along a survey line. In a refraction survey, a similar technique is used, except that the distance between the shot hole and geophone is very large, and that the travel time of the refracted waves is recorded. Refraction surveys give a large-scale picture of the area as compared to the reflection surveys.